Good morning all of you. In this video I am going to discuss about the real numbers of class 10th chapter number 1 maths. Let's start the discussion and move on. Numbers. There are two types of numbers, real numbers and imaginary numbers. So let's first come to the real numbers. Real numbers are the numbers which are denoted by the capital R. These are the numbers which can be represented on the number line. In integers, rational numbers, irrational numbers, square root, cube root, square, decimal, fraction, whole numbers, without roots. All these type of numbers comes under the category of the real numbers. Imaginary numbers are the numbers which are having minus sign under root. For example, minus 4 under root, minus 67 under root, minus 28 under root, minus 97 under root, and so on. Euclid's division lemma. It says that the given positive integer a and b, there exist whole numbers q and r, satisfying a equals to bq plus r, where r is greater than 0 or equal to 0 and smaller than b. Now let's come to the fundamental theorem of arithmetic. It says that the every composite number can be expressed as the product of prime numbers, and this factorization is unique, apart from the order in which the prime factors occur. Important concepts regarding this chapter are: P is a prime number and P divides A square, then P divides A, where P is a positive integer. To prove that root 2, root 3 and the numbers which are in root are irrational. Let x equals to P by Q be a rational number whose decimal expansion terminates. Then we express in the form of P by Q, where P and Q are in the form of 2 and 5m, where n and m are non-negative integers. HCF into LCM is equals to the product of the two numbers. The Euclid's division algorithm is named on a Persian mathematician named Muhammad ibn Musa al-Khwarizmi. An equivalent version of the theorem 1.2 was probably first recorded as the proposition of the 14th of book 9th in Euclid's Elements. Before it came to be known as the fundamental theorem of arithmetic, however, the first correct proof was given by the Carl Friedrich Gauss. Carl Friedrich Gauss is often referred to as the Prince of Mathematicians and is considered to be one of the three greatest mathematicians of all time. Along with the Archimedes and Newton, he has made fundamental contributions to both mathematics and science. Show that every positive even integer is in the form of 2q and that every positive odd integer is in the form of 2q plus 1, where q is some integer. Let a be any positive integer and b equals to 2. Then by Euclid's algorithm we can say a equals to 2q plus r for some integer q is either greater than 0 or equals to 0, and r equals to 1 or r equals to 0 because r is either equal to 0 or greater than 0 and smaller than 2. So a equals to 2q or 2q plus 1. If a is in the form of 2q, then a is an even integer. Also, a positive integer can be either even or odd. Therefore, any positive odd integer is in the form of 2q plus 1. Our next example is find the HCF of 96 and 404 by the prime factorization method. Hence, find their LCM. The prime factorization of 96 and 404. 96 equals to 2 into 2 power 5 into 3, and 404 equals to 2 to power 2 into 101. Therefore, the HCF of these two integers is 4. Also, HCF into HCM gives us the product of the two numbers. Therefore, after putting the values and solving it, answers come to be 9696. So that 3 root 2 is irrational. Solution. Let us assume to the contrary that 3 root 2 is rational. That is, we can find co-primes a and b where b is not equal to 0 such that 3 root 2 equals to a by b. Rearranging, we get root 2 equals to a by 3b. Since 3a and b are integers, a by 3b is rational. So root 2 is rational. But this contradicts the fact root 2 is irrational. This means our contradiction is wrong, so we cannot conclude that 3 root 2 is rational. So we can say 3 root 2 is irrational. Thanks for watching. Hope you like it. Jai Hind.